Alright guys, so today we're going to be solving a separable differential equation, but we are given an initial condition, so we're going to use that to go ahead and find our particular solution. So let's go ahead and begin by separating our y on one side. So we're going to move the y by multiplying and then the dx over to the other side. So what we'll get is y dy equals negative x e to the negative x squared. And we're going to go ahead and integrate both sides. So the integral of y, just real simple, just going to be y squared over 2 equals, over here we're going to have to use some u substitution. So this is going to be a bunch of fun. So let's let u equal negative x squared, the exponent. So du is negative 2x dx. And then we'll divide the negative 2x to the other side. I forgot dx needs to be right here. So we're going to go ahead and substitute this in. So we're going to substitute the du over negative 2x for the dx and the negative x squared right there. So we're going to have the integral of negative x e to the u times du over negative 2x. So I just substituted in the negative x squared for the u and the du over negative 2x for the dx. So let's go ahead and simplify what we got here. We have an x on the top and x on the bottom. It's all multiplying here, so we can cancel those out. Negative over a negative becomes positive. So we have the 1/2 integral e to the u du. And on the other side, we still have y squared over 2. And let's go ahead and find the antiderivative. So we'll have y squared over 2 equals 1/2 e to the u, where e to the u, well, u is the negative x squared. And of course, let's not forget our constant of integration right here. So we will have, give me a second, let me add some more space here for me. So we will have y squared over 2 equals 1/2 e to the negative x squared plus c. So actually right here, we don't quite exactly have the general solution yet because we need to multiply the 2 over, square root both sides, go ahead and get y by itself. But this is actually a good part where we can solve for c. So let's go ahead and bring in our initial condition, which was 0, 1, the point 0, 1. So what that means is that our x is 0 and our y is 1. So we're just going to go ahead and substitute that in and find our value of c so we can get that particular solution. So we will have 1 squared over 2 equals 1 over 2 e to the negative 0 squared plus c. So that's 1/2 equals 1/2. And then e to the 0, this just becomes 1 plus c. So our c is 0. So I'm going to go ahead and I'm going to take this c equals 0, substitute it back into c. Let me see if I can still give me a little bit more space. Oops. And I'm going to go ahead and substitute that in. So we'll have y squared over 2 equals 1/2 e to the negative x squared plus 0. So I'll just leave that the way it is. So now to get our particular solution, we need to go ahead and solve for y. So I'll multiply the 2 to the other side. So times 2 on both sides. This 2 cancels, this 2 cancels. We're left with y squared equals e to the negative x squared. And for our last step, we'll go ahead and square root both sides. And of course, when you square root both sides, you have to put a plus or minus. So our answer is going to be y equals plus or minus the square root of e to the negative x squared. Now the question is if we do the plus or the negative case of this. Well, if you look at our initial condition, the y value is positive. Anything coming out of a square root has to be positive. So, to have a plus in front would make that number positive. If it was a minus in front, it would make whatever number here ultimately in the end negative. So the fact that we have an output value that's positive means that we have to go with the positive case of this. So our final answer would be y equals the square root of e to the negative x squared.